Hey everyone! Welcome to the channel. Today, we're diving into an essential topic in chemistry, the priority order of functional groups. Knowing the priority order is crucial, especially when naming organic compounds. It's one of those foundational things that can make or break your understanding of chemical nomenclature and reaction mechanisms. So, what is the priority order of functional groups, and why is it important? Let's get started. Functional groups are specific atoms or groups of atoms within molecules that are responsible for the characteristic chemical reactions of those molecules. For instance, a hydroxyl group gives molecules their alcohol properties, while a carboxyl group gives them acidic properties. Different functional groups react in unique ways, and they're essential for understanding organic reactions. But when it comes to naming compounds, we need to know the priority order of these groups, because that order affects how we name and describe compounds accurately. The International Union of Pure and Applied Chemistry has set rules for naming organic compounds, called IUPAC nomenclature. When a molecule has more than one functional group, we need a way to decide which group takes precedence in the name. This is where priority order comes in. Priority affects two main things: the suffix and prefix we use when naming the molecule. The numbering of the carbon chain gives the lowest possible position to the highest priority group. Now, let's look at the priority order itself. The highest priority functional groups are usually those involved in oxidation states, like carboxylic acids, esters, and nitriles, and they take precedence over other groups. Lower priority groups, such as alkyl groups and halogens, are not considered functional groups in the same way because they don't affect the main suffix of the molecule. Let's discuss examples to see how the priority order works in practice. Consider a molecule with a carboxylic acid group and an alcohol group. Because carboxylic acid has a higher priority than alcohol, the compound will be named as an acid, with the suffix. The alcohol group will be named as a hydroxy prefix, like hydroxy, at the beginning of the compound's name. We have a molecule which contains both carboxylic acid and alcohol group. Now we know carboxylic group has a higher priority, so numbering start from carboxylic end. The compound name will be 2-hydroxypropanoic acid. Now, let's say we have both an aldehyde and a ketone in the same molecule. According to the priority order, the aldehyde group has a higher priority than the ketone, so we use the suffix for the aldehyde, while the ketone group gets the prefix. Look at the compound with aldehyde and ketone group. Aldehyde has a higher priority. The name will be 3-oxobutanol. In a molecule with an alcohol and an amine, alcohol has higher priority, so it will take the suffix, and the amine will be named as an amino prefix. Now, this compounds we know alcohol has higher priority. The correct name will be 2-aminoethanol. Why some groups take priority over others? The main reason is the oxidation state. Functional groups with higher oxidation states, like carboxylic acids, are generally given higher priority. This is because they are more reactive and have a greater influence on the chemical properties of the molecule. For example, carboxylic acids are more oxidized than alcohols or amines. They have multiple bonds to electronegative atoms, making them highly reactive and, therefore, influential in chemical reactions. Applying priority order in IUPAC naming. Now that we know the priority order, let's see how it's used in IUPAC naming. Here's the process. Identify the longest carbon chain in the molecule. Identify all functional groups attached to this chain. Assign numbers to the carbon chain, making sure the highest priority group gets the lowest possible number. Apply the suffix for the highest priority group and use prefixes for the other groups. This way, the molecule's name reflects both the structure and the functional groups in a clear, standardized way. Tips for remembering priority order. Here are a few tips and tricks to help you remember it. Start with the oxidized groups. Carboxylic acids are almost always at the top, followed by derivatives like esters, acid chlorides, and amides. If it's highly oxidized, it probably has high priority. Functional groups with COO. Aldehydes and ketones come next after the carboxylic acid derivatives. Oxygen versus nitrogen. Alcohols come before amines because oxygen is more electronegative than nitrogen. Use mnemonics. Create a phrase that helps you remember the sequence, such as cool scientists. Eagerly analyze. Amazing new alien knowledge about transforming atoms effectively. Each first letter could stand for a functional group in priority order. Thanks for watching. If you found this video helpful, like it. And don't forget to subscribe for more content. If you have any questions, leave them in the comments below. See you next time.